Right. I hope you can hear me clearly, people. So we have done three questions. First three questions in here. That's great. So give it to Atama. Acham, give it to Acham. Right. So we are done with the first three questions, and I asked you to try the last question. So now I'm going to perform the last question. Right. Some people have sent me the answers. So yeah, let me have the fourth answer right over here. So yeah, now when it comes to the fourth equation, you can find only two variables in the expression. So you have one input as A and the other input as B, right? So that means only four combinations can be happen: 0, 0, 0, 1, 1, 0, and 1, 1. Right? So this, of course, will help you to determine what kind of columns that you need to prepare. All right. And my pen start to give me the same experience. Never mind. So like we got three separate brackets over here, right? So these three separate brackets will help us to create the three separate columns in my truth table. So what I'm going to do is I'm going to create, I'm going to go with the first bracket. So I'm going to create B bar first, right? So B bar can be taken as 1, 0, 1, 0, right? And then I can have A dot B bar. So how I can going to take the A dot B bar just by referring to these two columns, A dot B bar. So 0 into 1 is 0. 0 into 0 into 1 is 0. 0 into 0, it's 0. 1 into 1, it's 1. 1 into 0, it is 0. Right? And then I got A bar dot B. So first of all, I have to create the A bar line. So A bar can be taken by referring to this column. So like 1, 1, 0, and a 0 is going to be there. And then A bar dot B. Now A bar dot B can be taken by referring to this as well as this, which we newly created. So the multiplication again happens 0 into 1, 0, 1 into 1, 1, 0 into 0, 0, 1 into 0, again a 0. Right? And then it's a simple column that we have to take care of, A dot B, which we can take with the A column as well as the B column. So multiplication 0 into 0, a 0, 0 into 1, a 0, 1 into 1, a 1, and 1 into 1. I'm sorry, the previous one is like 1 into 0. One into 0 is 0. 1 into 1 equals 1. Hold on a second, people. Right. Then it's a matter of adding up the things. Right. So what are we going to add? We are going to add up this particular column plus this particular column and plus this particular column. That's going to give me my output. A dot B bar plus A bar dot B plus AB. Right, so we are going to add up 0 plus 0 plus 0 will give you a 0. 0 plus 1 plus 0 will give you a 1. Because if you find a 1 in between any particular addition, you are going to have a 1. So 1 plus 0 plus 0 is 1 again. 0 plus 0 plus 1 is 1 again. So this is going to be the answer for the fourth. So who got this correct? Yes, people? Right, very good. Right, okay. All right, so people who have made any mistakes, it's time for you to do the correction. So I'll go for the next section within a minute. All right, so now so far in the lesson, we have learned what are the basic gates that we have and how those basic gates can be used to create the combinational gates, which is the NOR and the NAND gate. Then we learn when a particular circuit is given, how the output is created, and then when a particular expression or an output is given, how to create the circuit, as well as now we know when a particular expression is given, how to create the truth table. Now, let's move into your textbooks to see the very last part of your lesson. All right. So, let me take the textbook. All right. So, along the lesson, we discuss about these things. We discuss about the basic gates, which is AND, NOT, and OR. Then we talk about the combinational gates, which is NAND and NOR gates. Then we practice how to get the output out of a particular circuit. And now, as well as we have designed some circuits regarding the Boolean expressions, right? And now we are going to learn how these things can be used in practical, right? So in practice life, in practical life, how we are going to use these things, right? So you can find the gates inside these kind of ICs, which stands for integrated circuits, right? So what you can see here is a structure of a IC which consists of 4 AND gates, right? So it's easy for us to understand the working of this IC when we know what is inside that, right? So since these things are AND gates, right? These are AND gates. We know if we provide if we provide 0 over here, 1 over here, it will be a 0, right? As well as if you provide 1 over here and 0 over here, it will produce you a 0 again, because it is an AND gate. AND gate is capable of multiplying the inputs, right? So if you provide 1 over here, 1 over here, so this is one particular line, this is the other particular line. So you're going to receive 1. Right? So likewise, when it comes to the ICs, you can deal with these things when you know what's the operation of the gate. Are we clear with this, people?
Yes.
Right, great. Right, so I'm moving forward. So like when it comes to the this kind of an IC, so let's try to answer the questions which is given over here. So they say consider the integrated circuit given below. So first of all, what are the gates that they have used to create this integrated circuit? Yes, people? What are the gates that they have used to create this?
So they are OR gates?
Yes, that's correct. Utkarsha, Utkarsha. It's not O gates, it's no gates, Buddha. Right? So I think it's Saran who have answered me. So not Saran, the brother, neither. What's the name? Rison. Right? So yes, that is correct.
Sir, what I said?
Yeah. Hold on.
Sir, can you hear me?
Yes, Puta, I can hear you. Rison? Yes, I can hear you.
Okay, sir, we are experiencing a power cut, so I thought you can't hear me.
Yeah, at my place, I'm experiencing the same thing because my solar power system is repairing these days. So like, I have to go through the same. So, okay, so what you can see here is the no gates. All right, so let's see what are the answers for the questions that they have asked. They have asked, consider the pin 1, 2, and 3 in the above circuit. 1, 2, and 3. So that means these three pins. These 3 pins. And they are searching if 2 equals 0 and 3 equals 0. So what's the value of 1? 2 equals 0, 3 equals 0. Right, so if 2 and 3 is receiving 0, since it is a no gate, what's going to happen to the 0? They are going to add up and then will be inverted. So 0 plus 0 will be 0. And when it is being inverted, it will become 1. right? So that is how you are going to deal with this. Right. So let's move to the second question that they have. Okay, people, tell me the answer for this. Yes, what's going to be the answer for this?
0.
We'll see, we'll see. What is the gate type that we have used here?
NAND gate.
Yeah, it's the Nand Gates, right? So Nand Gates, what is the operation? So like it will multiply and inverted, right? The inputs will be multiplied and then inverted. So how it will be multiplied? Pin 1 is 1 and pin 2 is 1. So 1 into 1 will be 1 anyway. But since this is a NAND gate, the multiplication will be inverted. So 1 into 1 will be 1 and it will be inverted into 0. Right? So 1 is given over here. If this is 1, if this is 1, this is a 0 that you are going to receive. Yeah, people, is that clear? Yes, everyone? Are we clear with that?
Clear, sir.
Right, great, great. Okay, so now we are coming to the very last part of the gates. And this is the place you are going to receive the question as well, right? In the question paper, I'll show you some questions. Yes, Susu? Right, then this is what we call practical usage of logic gates. Now, the example that they were using in the book, we will go through the example, but it's a little bit confusing when the way they have implemented it, right? So anyway, I'll go through that, and I'll show you some other example as well to make the things get much better in that place, right? So like now, this is the way that you are going to receive the question as well. They will be you will be given.
This means,
Yes, Rizwan.
so sir, in the exam paper from this whole lesson, they are giving only from this part. Oh,
This part needed all the knowledge that you have taken in the other parts, Rizwan.
okay, sir.
All right. So this is talking about a practical situation. So they are talking about home alarm system. Right. So it says the circuit given below is an alarm system which informs the house owners of a theft at home. Right. This is designed using OR gates. The circuit protects two windows, two front and back doors of the house. Where any window or door is open, an alarm system will be on. The logic gates, which is connected to the windows and doors, are connected to the sensors. Right? And input is 1 when window or door are open. Input is 0 when window or door are closed. right? So what they are like trying to express from this, right? Just read it through, people, and give me a second. I will be right back. Okay, so first of all, when something like this is given, you have to recognize what kind of a situation is this. And again, through the scenario, you have to determine what are the inputs and what is the output that is controlled by the inputs, right? So now, according to this scenario, how do you feel? What should be the output? Yes, people, in this system, what indicates the output? Which device, or like which part gives you the output? Yes, any suggestions? Okay. So this is, now let's think about it in a practical manner, people. This is a home alarm system. So there will be a home, right? And it says this home has 2 doors and 2 windows. Right? So here it says, when any window or door is opened, an alarm system will be on. Right? So that means alarm is the one which is acting as an output, right? Because alarm is going to buzz off when any particular door or window is open. That means those things need to be closed at all the time, right? So it says the logic gates which is connected to the windows and doors are connected to the sensor, right? So in simple terms, there are sensors in each and every point. So this particular sensor points will indicate like when needs to be have the alarm. Right. So that means, so let's say alarm is right over here. Right. So since the alarm is the one which indicates the output, it is controlled by these 4 things. What are the 4 things? The sensors which is connected to the 2 doors and 2 windows, as well as those are the one who sends the input signal, to the sector. Right? So the circuit will receive the input signals through these lines. Got it, people? Are you clear with this?
Yes, sir.
Okay, how about others? Are we clear with this? All right. Now let's assume, not assume, now the scenario says, okay, so the scenario says the logic gate which is connected to the windows and doors are connected to sensors. Input is 1 when window or door are open. So that means some right. People, hold on a second. My pen is not responding. I have to switch to the board. Wait, so all right, people, can you hear me clearly?
Yes, sir.
Right. Okay. So now we are given this particular house, and it has an alarm system, and that alarm system is connected with 4 sensors, which is connecting from 2 doors and 2 windows. Right? And it says input is 1 when windows or door are open. So this door and windows has 2 states. Right? So since there are 4 doors, I'm sorry, 2 doors, I'll take it as door 1 and door 2. Right? When it is open, it indicates 1. When it is closed, it indicates a 0. And for this door 2 as well, when it is open, it indicates 1. If it is closed, it indicates a 0. Same goes with the 2 windows. So always there are 2 states for the inputs, which is controlling the output. Right? And right, where that comes to. So what they are asking you to do is, by considering this thing, this particular details that is given to you, try to come up with a circuit. In the explanation, they have given you some help as well, but the things are much easier and much sufficient for us to come for a solution. Right? So let's see how the solution can be built. right? So what we are having is the inputs that we have is like do1, do2, window1, and window2, right? As well as we know, if it is open, it indicates 1. If it is closed, it indicates a 0. So same goes with the all other inputs, right? So the output is the alarm, and when the alarm is on, it indicates 1. When it is off, it indicates 0. Right? And what is the relationship in between inputs and outputs? We can describe the relationship like this. Describing relationship in between inputs and outputs. How the relationship happens? The scenario says if any of the window or door is open, alarm is going to buzz off, or like alarm is going to indicate there is a threat. Right? So when I'm writing the relationship, I need to involve all 4 inputs into my relationship. So how I'm going to say? I'm going to say it like this. I'm starting from the output. Alarm will be on when door 1 is open or door 2 is open when I take the word O to some this. Or what's the other? What's the other? Yes, it's going to be window 1 is open or window 2 is open. Right? Now, when it comes to the Boolean expressions, we won't find any words inside. So we can find only the variable kind of things. So it's better we apply some variables to the to our inputs at the initial stage and convert this description with the variables, right? So to do that, I'm going to take some variables. So I indicate alarm by A and my door 1 by D1, door 2 by D2, window 1 by W1, and window 2 by W2. Yeah, people, are you clear with what I have written as the description, as well as the way that I have taken the variables? Is it clear?
Clear. Clear.
Right, great. Now I'm going to convert my description into a statement which has the variable. Sakis are going to be here, Suzu. Like they will take some of the time, then they will do that. Right? That will be finished. Hold on, now you play with your sample, then after you play. Right. Now what I'm going to do is I'm going to convert this description into the variables. Right? So how I'm going to do? This is the way I'm going to do. I'm going to rewrite the description with the variables. And before we go to the variables, people, I need to before we go to the variable description, I need to show you how the variable goes with these states. How this open state is indicated, how this closed state is indicated. Right? So how I am going to indicate those two using the variable that I have proposed here. So door1 is indicated by D1. So door1 is open, can be indicated as D1 as its natural state. Close can be indicated as D1 bar because it's the not meaning that we have. Are we clear with it, people? So 1 is taken as the natural state or the way that the variable is. 0 is taken as the complemented state. Are we clear with it, people?
Yes.
Right. And how about the alarm? Alarm on can be indicated as A. Alarm off can be indicated as A bar. Simple as that. All right. Got it, everyone? Okay, great. So now I'm going to write my description with the help of the variables. Right? How I'm going to do this? Here we go. So when I'm writing it, yes. When I'm writing this, I need to consider what state that they are indicating. Right? So alarm will be on. That can be indicated as A, not A bar, right? A. Then I can take my English word when. So for when, or like since it is showing me the relationship, now it has when. Door 1 is open. Door 1 is open. How am I going to indicate it? D1. Then it has the word O. Door 2 is open at the next part. So that means D2. Then I have O. Window 1 is open. That means W1. Then I can say O. Window 2 is open. Go ahead and indicate. People, is it clear how we came from over here to over here?
Clear, sir.
Right. Now, it's a matter of converting these small words like when, or, and all these things into a mathematical operator, or in other case, the Boolean operators, right? So this indicates one. The output is A, right? Alarm is the output. So A equals, because output is the one which is going to be equal to the input combination, or like the or the operation of the inputs. So A equals, we can say D1 plus D2 plus W1 plus W2. Right? So we have taken a very simple expression. So now it's a matter of drawing the circuit, right? Because we have an expression now. So how we are going to draw the circuit? We have 4 inputs. Either we can have 4 input lines. So in the expression, we only need to add these things up. We can simply draw it like this, people, right? First method of drawing the circuit. Drawing the circuit. So we have the expression at the top. This is method 1. Right, we can easily draw something like this. I'm sorry, not A. We have taken some input lines, so input lines are going to come first. So D1 will be here, D2 will be here, D3 will be here, D4 will be here. We can take all the inputs, run through a one single OR gate. This gives us A. Right? This is a one way of drawing it. But in your syllabus, they say consider OR gate which has 2 inputs, as it has 2 inputs. So according to that method, if we are going to draw this, we can go on this, like D1 and D2 goes through a OR gate, and W1 and W2 goes through another OR gate, and the output of these two flows through another OR gate, right? So when we do that, we have D1 plus D2 over here, W1 plus W2 over here. So we're receiving the A output once these inputs flows through this OR gate. People, are we clear with this?
Clear.
Yes, everyone? Are we clear with this?
Okay, clear, sir, clear.
Right, great. Okay. So let me walk you through this again about the things that we have done. I better write at the top. So first what we have to do is like determine or like determine inputs and outputs. Output, it's better to say because only one output will be there in your syllabus. And most importantly, their status. Which indicates one and zero. Right? So we declare what is inputs, what are the outputs, and we determine how the states are going to be. Right? So when we are like introducing the inputs and outputs, so like declaring the inputs and outputs, we propose the suitable variables as well. So we can easily get a particular formula or an expression using those variables pretty easily. Right? So we determine the inputs and outputs. That's the thing that we have to do first. Then we determine what are the two states for these inputs and outputs, which indicates one, which state indicates zero. So according to the door, we took open as its one state, we took closed as its zero state. For the alarm, we took one as its on state, we took zero as its off state. All right, and then we describe the relationship in between inputs and outputs. So, which simply says how the output is handled by the inputs. Then we convert that description into the form of variables. Then, with the help of the variables, we draw the circles. Simple as that. So, are we clear with this, people?
Yes.
Right. Great. So, it's better we write down these steps, people. So, before we come into this part, we go through the scenario, right? Then I'll take you through this writing part that we have done, right? So, first of all, let's have the heading. Practical usage of logic gates. So have the heading practical usage of logic gates. I'll highlight the things. Right after that, under that heading, let's write about this sentence. Right, so put a star or a point and you can say, let's say it like this. Let's consider following scenario. Let's consider following scenario in creation of logic circuit. In creation of logic circuit, in creation of logic circuit using basic logic gates. Using basic logic gates. So then you can write the scenario. I'm going to tell you, hold on. Yeah. Right. So under that, it's better you start this sentence with the letter A. Right? A means not this over here. Instead of this, you are having a circuit protects. So there should be the letter A. A circuit protects. A circuit protects two windows, the front and back. Two windows, the front and back doors of the house. When any window or door is open, an alarm system will be on. The logic gate, which is connected to the windows and doors, are connected to the sensors. Input is 1 when windows or door are open. Input is 0 when windows or door are closed. So write down that scenario.
Sir,
Yes, Rizwan.
sir, I had a connection problem, sir. I meant my computer was disconnected.
Okay.
What? Yeah.
So yeah, we wrote the heading practical usage of logic gates, and we
Yes.
wrote a one
Sir,
sentence.
sir, I wrote, let's consider following scenario in creation of logic circuits. After that,
Great. Then you only have to write the scenario, the one that I have highlighted here. So you better start it with the letter A. A circuit protects two windows likewise. So write down the highlighted part. That's all, units. Dulandi, we have written this topic. Under that, we have written a one sentence that, of course, you can refer it from the video viewer. And okay, Dulandi has disconnected again. I think it's because of this power cut and all these things. Let's see. Yeah, Dulandi, can you hear me clearly, viewer?
Yes, sir.
Right. So I have given this topic, and we have written a sentence under that. Then after we have written this highlighted part. Right. So the sentence that I have mentioned, it's better you refer the video and write it down. Right. Or can someone post that sentence to the chat? So people who are missing that sentence can refer.
Sir, I put it to the group.
Rizwan?
Recording
But Rizwan, I'm getting an echo.
Sir, I posted it in
Ah, great. Thank you, Rizwan. Thank you very much.
group.
Okay. Thank you very much. Rizwan has posted in the chat, so
Sir, the group chat.
you put it in the group. Ah, okay, that's better, much better. All right, are we done with this scenario? Anyone who is still writing? All right, so moving forward. So, like after this paragraph paper, we have to add a little to this paragraph, to the same paragraph. So your paragraph is end input is 0 when windows or door are closed. So then continue the same paragraph with this. On state of the alarm, on state of the alarm, on state of the alarm.
Sir, can you say it again?
On state of the alarm, on state of the alarm will be considered as 1, will be considered as 1, and 1 means like numerical 1 you have to write, right? Like it says input is 1. On state of the alarm indicates 1, and off state of the alarm indicates 0.
Off state of the alarm
indicates 0. 0 is the numerical 0 that we have to write, right? 0. On state of the alarm indicates 1. Off states of the alarm indicates 0. Okay. So the next line, let's write it like this. Let's go like this, people. To create the circuit, 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 following steps needs to be followed. To create the circuit, following steps need to be followed. Right. So then after you have the note on the board, so you can go with that. So steps are given with the star mark, so you can go with that and indicate the things, right?
Sir, should we write down this?
Yes, Lison, you have to write down this.
Sir, can you ask a bit?
All right, if you are done with the upper part, I'm scrolling up a little. If you miss anything, let me know, right?
More down, please. Drawing this up.
Anyone who is still writing?
Done, sir.
Okay. So I'm moving upward. If you miss anything, just let me know, right? Yes, everyone, are we done?
Answer.
Anyone who is still writing? All right. So let's go and see the second example in your book, right? I think you are having a little idea about this, how the scenario can be maintained with this kind of work. So let's go and see how the second example works, right? So as it shows, you can see the circuit that we have created. It's designed from here, right? It's the same circuit, right? So they have shown you several different scenarios of it with some input values. And this is the truth table of it. And people, it's pretty big. And don't worry about the truth table for the moment, because now in your syllabus, we are advised to have only for 3 inputs, not for 4 inputs, right? So the second example that they are trying to talk here is the street light thing, right? So what they are trying to introduce you, like to explain to you, is like there is a street light which is going to be on or light up when the darkness is there, as well as it has a manual switch that we can on and off the switch as we want, right? And I wonder, like, can anyone cross-check, is it the same 3 sentences that is there on your book as well? Because in my copy, the first and the third sentence was the same way. Is it the same in your books as well, Peter?
Sir, when only the manual switch is closed.
Okay. Second one,
the input of the time is 1, and when the environment is dark, when only the manual switch is closed. That's what I have.
yeah. That means the third one replicates the first one. Like it's the same thing, first and the third. Right? So we can omit the very last one, right? So I think this need to be connected like this. There are several occasions when the lights are on. These are when only the manual switch is on. Closed means on, like you can close here like the scientific meaning. When the manual switch is something like this, right? So this is the open state. So if the circuit goes like this, so when this is closed, then only the light is going to be light up, bulb is going to be light up, right? So in that meaning, they have taken the word close, right? When only the manual switch is closed. And again, when the input of the timer is 1 and when the environment is dark, right? So it is talking about, again, 3 different inputs, people, right? One is the switch, the other one is the timer, the other one is the environment is dark. That means it is sensed by this dark and light sensor, right? So what we can indicate is these 3 inputs: dark light sensor, the timer, and the manual switch is controlling the street light, right? So manual switch, once the manual switch is closed, bulb is light up. When it is open, bulb is not lighted up. And according to the second condition, when timer is 1 and when the environment is dark. So timer may have 2 states, 1 and 0. And the sensors two states are like the dark and the light. So dark can be taken as 0, light can be taken as 1. Right? So likewise we can argue. But in the latter part, they have described you what kind of situation that these things are going to have. Right? So I'll give you this rough idea. So you go through the second example at home. We are going to discuss it by next week. Plus, we are going to go for the new lesson as well, right? So, since it is the very last part, we are doing things. Without going to the new lesson, people, I'm going to show you some exam questions which is related to this lesson, right? So, we will discuss about this second example, and we will do some questions plus past paper questions by next week, right? So, go through the second example. I'm going to explain it by next week, and we'll do some questions and we'll go for some past paper questions as well. Right? So I'm going to end the session from here just for today. Thank you very much, everyone. So I'll see you on next week for the very same time. Right? All right. Thank you very much, everyone. Good night.
Thank you, sir. Goodbye.
Thank you.